Okay. Hello, BNS 380. We are going to finish out female sexual behavior. I have about 20 slides to get through, so hopefully this video won't be too terribly long. I'm coming at you from The Tonight Show today. I love Jimmy Fallon. And I'm wearing Christmas colors. Unintentional, but you know, I did take a shower for y'all today, so we're winning today. Okay, so as we've talked about, sexual behavior in general, especially when it comes to humans, is really understudied. And so when you're considering female sexual behavior in particular, it's tough to narrow it down to phases. So with males, we have the consummatory and the appetitive phases, or rather appetitive and then consummatory phases. So we only have two phases of male sexual behavior. But for females, it's a little bit different. How do we quantify female sexual behavior and how do we organize it? So there's a couple ideas. Maybe it's 6 phases. You have the courtship, the mating, ovulation, pregnancy, giving birth, and then feeding the baby. But that seems a little excessive and very baby-centered. And we'll get into all this when we get into parenting behavior. But then there's the idea that maybe there's just 3 phases. Copulatory behaviors, of course, all the behaviors involved with mating, paracopulatory behaviors, which is all of the behaviors to try to obtain a male, and then progestive behaviors, which are the behaviors to try to increase your reproductive fitness. But the one that we are going to talk about, and the one that's pretty much been the most definitive, is attractivity, proceptivity, and receptivity. So attractivity is just how attractive is the female to another male. So this is how attractive is she for a male, and things that she can do to become more attractive to the males, for the males. And then there's proceptivity, which is all of the behaviors involved with trying to get a male. And then there's receptivity, which is the actual being receptive to a male sexually. Okay, so let's talk about attractivity. Of course, most of this research has been done in rats, as you can imagine. So first, we are going to talk about what a female can do to be more attractive to a male, so that a male will actually want to mate with her. So there's a lot of evidence, especially in rats, of course, that suggests that estrogen actually increases attractivity. So males are more attractive to females when estrogen levels are high. We talked about this a little bit when we talked about the different studies, when we talked about human sexual behavior and about how the strippers that are ovulating get a lot more cash than those that are not. So you have to remember that estrogen levels increase throughout the follicular phase. They're increasing until they get to that really high moment where then you get the LH surge. So as estrogen increases, this is a time when females are more attractive to males. Males will find them more attractive, and this does seem to be true for humans as well. Ovary ectomized females are not as attractive to males. Males will still mate with them, if they can. If they do, some females that are ovary ectomized will still perform lordosis behaviors, and so then the males will mate with them, but generally they are not as attractive to other males. Okay, and this really makes sense when you think about it, because as estrogen increases, that means you're getting close to ovulation, so that means that a procreation is more likely to occur. So progesterone does seem to decrease attractivity. So males are less attractive to females that are in the luteal phase. This is when progesterone levels are higher and they increase. And of course, this makes sense because fertilization is not possible in the luteal phase. So there is no way that pregnancy can occur. And progesterone is also really high when a female is pregnant. So therefore, she is also unable to get pregnant again, right? So it makes sense then that males should spend their time elsewhere to spread their seed, right? So if a female is already pregnant or she is unable to get pregnant, then it would behoove him to spread his seed elsewhere. This is probably no surprise to you all. You guys have probably heard that males are more visually stimulated than females, and there is some fMRI evidence to support this, that the actual visual areas of the brain do seem to be active in about the same amount as females, so this is the same. But whenever males are observing visual stimulation, there is more activity in the amygdala and there is more activity in the hypothalamus. So this would suggest that when presented with visual stimuli, that these areas involved in mating and copulation are more active. And this is for humans because rats are not very visual. Also, female rats in particular, and this is probably true for humans as well, when the female is the one like saying, hey, come on, let's go, then that female is more attracted to the male. The male is more likely to go with that female that is initiating and making the movements than one that is not. Okay, so let's talk about this horse. This is what hooven animals will do, is that they will make this funky face. This is called the Flehmen response in this picture here. And what the Flehmen response is they do this because the vomeronasal organ is just in this area here. And so the scent will come into the gums and the horse will actually push with its tongue up to the roof of the mouth, which will push that scent into the vomeronasal organ, the scent of females. So horses will do this, and other hooven animals will do this to sense a female in estrus. So once a male has mated with a female, then she becomes less attractive to him. Right? He's already had his chance with her. And again, the goal is to spread the seed as far and wide as possible and mate with as many females as possible. So as males do copulate with a female, she becomes less attractive. And this is true for females that have already been mated with. So other female rats that have already been mated with are also less attractive to new males because, again, there's already been a male there, and so the chances that he will be able to procreate with her is lower. And we talked about the Coolidge effect, about how a new female will rejuvenate a male, but this is actually the opposite for females. So on that same note, let's talk about the vomeronasal organ a little bit and pheromones. Again, this is an important organ, especially for rats. So we're going to talk about some pheromone effects. This should be familiar from you all for 295 when you guys took 295. So this is, of course, the scent, the smell that is put off and received by males and females. And this is how rats are able to tell the difference between males and females, is because of pheromones. If you take out the vomeronasal organ, they're unable to tell the difference between males and females. You can no longer tell the difference. And as we talked in a previous lecture, that this organ does have lots of neural pathways to the hypothalamus, to those sexual responses. So what generally happens is that signals from females to other females suppress reproductive activity, because again, we're talking about female reproductive behavior. So when we're talking about female reproductive behavior, signals and pheromones from other females suppress that reproductive cycle, where the scent of urine or other male pheromones will accelerate that reproductive response. Okay, so here are some effects, and again, these are some effects that you should already be familiar with from 295. The lead boot effect. This is whenever you have female rats and they're all housed together. There is no scent of any male, so having these females around, and only females, will cause the females to stop cycling. So they will go into anestrus, because again, there's no male around, so there's no chance of pregnancy. So their cycles will just cease. As soon as you present any sort of male urine smell, then they will start cycling again. So that's the lead boot effect. When females are all together and there is no scent of any male, they will eventually go into anestrus. In the Vandenberg effect, this is whenever puberty is actually increased or delayed depending on what they're exposed to. So with the Vandenberg effect, when you have infant females and they're only raised around females, so there are no males available, then puberty is actually delayed for those females. On the flip side, the female, for the Vandenberg effect, on the other hand, if these juvenile females are exposed to the scent of male urine, then they will actually go through puberty faster. So if they're only around females, puberty will be delayed, and if they're only around males, then females will mature faster. Then there's the Bruce effect. This one is kind of crazy. This is whenever a female is already pregnant, but if a new, more suitable male shows up, she will abort so that she can get pregnant by the new male. So that's the Bruce effect, which that's pretty wild. And then there's the Witten effect, and this is whenever you do have males present, but you have females that are housed together. All of those females will start cycling together, and this is known as the Witten effect. So they'll all go into estrus at the same time. This makes sense because therefore, if the male comes into play, then he can just mate with all of them, and they'll be good to go. Okay, so what about humans? So there have been some studies that looked at the Vandenberg effect in humans, like girls with brothers, and whether they go into puberty earlier, and there's no evidence that anything like that necessarily happens. Maybe, it's unclear. But there's definitely a lot of evidence of the Witten effect. Maybe some of you ladies that have female roommates, maybe you guys have noticed that maybe your cycles will sync up if you're not on birth control. So this is a real effect. This does happen in humans where women will sync up when they've spent a lot of time together. And this has been shown to be due to pheromones. So there is something going on there for humans. And again, do we have a vermonasal organ? Yes. Some people suggest that we don't have one at all, but a lot of evidence does suggest that we do have one. It's just really, really small. So pheromones do not cause our behaviors as much as it does in other animals. Also, androstenedione, there's been some studies that suggest that, so this androgen is released in male sweat, and there's been studies that have put this under the noses of homosexual and heterosexual females. And there's been studies that suggest that this does have an effect. There was a study done, I don't know if I already told you guys about this, but there was a group of women that they brought in. So they had a bunch of men, and they all wore just white plain t-shirts, and they all played basketball and got real sweaty and gross. And then they took all those t-shirts and they put them in a pile. And they had women come in, and the women smelled the shirts and put them in categories of either attractive or not attractive, put them in piles. And what they found is that women who are cycling normally, so women not on birth control, sorted those shirts in the same piles every single time, the same way. So the same men, they found the same men attractive every time, and the same men, the same t-shirts not attractive every time. It was different for different females, but each female sorted them all the same way every time. The only people that messed it up were the women that were on birth control, and they messed it all up. They weren't able to do it. So there's something to that. And so it's thought that androstenedione actually does activate the hypothalamus, but this tends to only be true in heterosexual females. This is also true in homosexual males. Androstenedione will also activate the hypothalamus, but in homosexual females, androstenedione does not activate the hypothalamus. So that's pretty interesting. Okay, so that's attractivity. Attractivity is how attractive a female is to a male. So now let's talk about proceptivity. And so this is the appetitive responses. This is similar to appetitiveness in males. So this does not include copulation. Instead, this is all the activities that females do to try to get a male partner. So this is, again, the appetitive response. This is the same. And so when females are, when estrogen is increasing, females do tend to, heterosexual females, of course, do spend more time around males. They want to be around males. They're seeking out male partners. Even if the male's like, nah, girl, don't get near me, the females will still try to be around males because, again, she's about to ovulate. So it's time to get on it. So this is measured in rats, and you can see this little graph over here. Female rats will do this funny thing where they wiggle their ears and they jump around and they hop over, and males find it irresistible. They love the ear wiggling and the hopping. And the female will go around and hop near a male, and then she'll touch him, and then she'll run away, and she'll go up and touch him and run away. And males find this really, really sexy. So this is proceptive behavior in a rat. And so this is a way that the female is saying, hey, 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 I'm ready, let's mate. And so this is this approach and withdrawal method. You could think about this for humans. Do humans do this? It's interesting to think about. So this can be measured by how many times the female does this to try to get the male to mate with her. Okay, so receptivity, this is similar to the consumatory phase. This is when the sex is actually happening. And this is measured by the lordosis response in female rats. So this is known as the lordosis quotient, also known as the acceptance quotient or the rejection coefficient. So these are different ways to measure. And this is just how many times the male will attempt and how many times he is actually successful. So does she perform lordosis? Does she allow him to intromit? These types of behaviors is how it's measured. If you ever do sexual behavior research in rats, that's how it's measured. Something interesting about ringneck doves, if any of you guys do research with Dr. BC, she has ringneck doves. One thing that happens with the females is that they will coo when they are receptive, and when they coo, this cooing actually will cause their follicles to develop and will cause estrogen to be released so that they are more attractive to males. I thought this is real interesting. If you take out their vocal cords, then this effect is reduced. So there is something where their own cooing will feed back for them. Okay, so this is really interesting about how females do tend to control the timing of copulation. So it seems that in order for a female rat to become pregnant, that multiple intromissions are actually necessary. And it seems that somewhere between 5 to 10 intromissions are actually what is preferred. This has the most success for pregnancy in a female rat, and this is known as the vaginal code, which is pretty funny. But she can mate, of course, we're talking about rats here, so she can mate with multiple males multiple times. So she can go, and generally the first male and or the last male are the most likely. So if you're a male rat, you want to be either the first or the last to mate with her. And it does seem that just one intromission is not sufficient to cause pregnancy, because what happens is if there's only one intromission, then that corpus luteum, which is required, to release the progesterone in order to grow the endometrial layer so that a pregnancy is able to occur, will actually not happen if there's only one intromission. So with these multiple intromissions, prolactin is released, and this will actually cause the corpus luteum to stay there and keep releasing progesterone and keep building that endometrium layer. And again, this is only for rats, but that's pretty cool. Okay, so now I'm going to talk a little bit about the neural network here. I only have a few more slides and then we'll be done with this video. So here in the ventromedial nucleus, this is the nucleus that's most important for female sexual behavior. So we have the preoptic area that's really important for male sexual behavior, and then we have the ventromedial nucleus, which is important for female sexual behavior. So this is where you will find a very high density of estrogen receptors. You do need this nucleus in order for lordosis to occur. So you do need the brain in order for the rat to perform lordosis. So this is a major estrogen circuit. So you do need both of these available in order for lordosis to occur. So you need estrogen and you also need the ventromedial nucleus. So if you take out the ventromedial nucleus, you're also abolishing this estrogen circuit that goes to perform the lordosis response. So both of these things are required together in order for lordosis to occur. So let's talk a little bit about estrogen receptors. Both types are found in both areas. I do want to point out that the ER beta and ER alpha, we just don't know that much about these estrogen receptors. There still needs to be a lot more research done to learn about these. So it's real difficult to do research with these estrogen receptors. So this is an area that really needs more study. So with ER knockouts, this is all estrogen receptors are knocked out in these rats, all of them. So lordosis doesn't occur. They're also more aggressive, and hormones are not regulated as well as they normally are. So clearly these estrogen receptors are required. So this is when both types are knocked out, ER alpha and ER beta. With just beta knockouts, estrus is actually extended, which is really crazy. One thing that's important to think about with these estrogen receptor knockouts is that it's missing all over the place. So these mice, they're mice, are born and raised without any estrogen receptors anywhere. So it's unclear whether it's the central nervous system ones that are causing these effects, or is it the fact that they're also out of all of the ovaries, it's out of the bone, they're not available in the blood vessels. So all estrogen receptors, which are found in many, many tissues throughout the body, they're all gone. So that's important to remember. It seems that for estrogen, like estrogen, estradiol in particular, is what causes progesterone receptors to be created. So estrogen causes progesterone receptors to be created in the body. So that's pretty cool. Okay, here's just some other things that are going on. Serotonin inhibits lordosis. Serotonin is just really bad for sexual behaviors. If any of you guys have ever taken antidepressants, SSRIs, sexual effects are very, very common and a big major complaint from a lot of people that take SSRIs for medication. So serotonin, this is true for males. We talked about the serotonin circuit, serotonin in the spinal cord, and how it can prevent delay or prevent erections. It does definitely delay or prevent ejaculations. So, which, you know, better or worse, right? But it certainly does inhibit lordosis, and it does decrease desire and orgasm in females as well. So dopamine and norepinephrine are, of course, involved. Dopamine does stimulate lordosis. Remember, we're still talking about something that is a rewarding behavior, so we do need dopamine there. One thing that's interesting is that whenever D1 is activated by that increase in dopamine, then progesterone receptor activity increases. So again, this like, okay, here comes ovulation, we're going to have sex, we need to get ready for pregnancy, so we need to have these progesterone receptors available for when we have progesterone being produced in high levels. So that's pretty interesting to me about that. And then oxytocin. Well, we're going to talk about oxytocin when we talk about birth. Oxytocin is released from, so there are stretch receptors in the vagina, and when the vagina is stretched, those receptors are activated and tells the brain to start releasing oxytocin. So you start building that trust, you start getting that social recognition, all of that oxytocin brings in, you know, the social bonding that it does. So that's why you catch the feels from, you know, one night stands and things like that. So oxytocin, when it's released, it increases the lordosis behaviors. So having that close contact is good for rats. There are receptors for oxytocin in the ventromedial nucleus of the hypothalamus. When estrogen is around, so estrogen is increased, then there is an increase in binding of oxytocin. So you're more likely to have that social recognition. You're more likely to have that bonding closer to ovulation because there's higher levels of estrogen. So that's really interesting. And it also causes norepinephrine to be released. So when oxytocin is present, more norepinephrine is going to be released, which this makes sense, right? This is your fight or flight. This is going to get you moving. This is going to get you activated. This is going to cause you to have more action-oriented responses so that you will go and seek out these new partners. All right, so that's all. That's all for female reproductive behavior. You now have enough information for the quiz, which I'm going to send out in a couple hours. So stay tuned.